Okay, as we look at the do now, we start with two equations that we need to solve. With the first one, we have this addition, or we have this subtraction. I'm going to quickly switch it to adding a negative. So I have 4h plus negative 9, and I need to add 9 to both sides. It's going to give me 37 plus 9. So remember really quickly, that's the property of equality. That says that we can add something to both sides and it's still going to make a true statement. So we've added 9 to both sides. This negative 9 and this positive 9 add up to 0. That's 4h plus 0 is equal to 46, which tells us that 4h is equal to 46. Again, this is using the additive identity to recognize that anything plus 0 is just itself. So now we need the inverse operation. I'm going to divide both sides by 4. That gives me 4 over 4h is equal to 11.5. So along the way here, we divided both sides. That's also the property of equality. We did the same thing to both sides. And we also are going to have this 4 over 4h. That's really just a multiplication of 1. 1 times h is equal to 11.5. So again, one thing that we always see is that we have operations where we have a property of equality. We're doing the same thing to both sides of the equation, leading to an identity property. So we see that happen twice here. Property of equality leads to additive identity. Property of equality leads to multiplicative identity. And again, just remembering the order of operations, we're doing them in reverse order since we're doing inverse operations. And that's why we did the inverse of the addition and got the additive identity, and then the inverse of the multiplication and got a multiplicative identity. So that's really the key point about how we go through and solve equations. Now the other key point comes in over at this second problem where we see something that's not a two-step equation. It's not like the ones we've seen before. We see that there's parentheses there, so we could go ahead and do the inverse operation of this multiplication first. But in general, when we want to solve equations, it's usually easiest to simplify the equations first. So looking at this, we can simplify this by distributing 2/3 times h and 2/3 times 9, so that's 2/3 times h plus 2/3 times 9. I can do the quick math over here. It's going to give me 18 over 3, which is 6, is equal to 36. So now I'm going to do my additive inverse. By the way, we can, if we needed to, we could say we did the distributive property here. Alright, so I'm going to add negative 6 to both sides. 2/3 h plus 6 plus negative 6 is equal to 36 plus negative 6. This adds up to 0. We added the same thing to both sides, so again, we have a property of equality. Doing some operation to both sides. It's an inverse operation. So it's going to give me 2/3 h plus 0 is equal to 30. And here we have the additive identity. It tells us that 2/3 h is equal to 30. So again, I need to do something here that's going to lead me to, I'm going to need to do a property of equality that's going to lead me to a multiplicative identity. So we've got a multiplication. So the multiplicative inverse here, we would say, is to divide. Divide by 2/3. Well, dividing by 2/3, we would actually end up saying, alright, we're dividing by 2/3. That's really the same thing as multiplying by its reciprocal, 3/2. So I'm going to go ahead and show this here, that I'm multiplying by 3/2. And I'm doing that to both sides, so here I can see my property of equality. That's going to give me 6 over 6h is equal to 90 over 2. This is really just a multiplication of 1, so again we see that multiplicative identity leads us to our answer. So again, we can see over and over again, really what we're thinking about here, if we're doing this multiplicative inverse, we're looking to get some form of 1 here. And again, that really always just turns out getting the same thing on top and the same thing on bottom. So we end up here with our answer is h is equal to 45. Today, our aim is to solve real-world problems with equations. We're going to solve real-world problems with equations. And as we go through this, this is really just review and putting the pieces together from the rest of the unit. So actually the way that I'm going to handle this video today is I'm going to go through and for each part I'm going to give you some hints, some things that you might think about. And I'm not actually going to give you the answers because I want you to be practicing this like it's going to be the test that you're going to be taking tomorrow. Then at the very end, once we've gone through every single different piece, then I'll go ahead and kind of walk through the answers for you so you can check your understanding, because that's what I really want you to be able to walk away with today is, where does my understanding lie? How well prepared am I already for the test? And what do I need to do to make sure that I am prepared for the test? So starting here with the teacher time, I want you to go ahead and walk through the problem. Again, you should try to do this on your own. And then if you feel like you're stuck and you need a hint, then you can kind of press play on the video. I'll give a couple hints here and there, and then you can try and finish it up with those hints. And then if you can't, then you'll want to go ahead and move on to the next problem, and we'll give more hints in terms of how to solve it kind of at the end of the video. So that's kind of the way it's going to be set up today. So go ahead and pause the video right now and try this on your own. If you get stuck somewhere, go ahead and start the video up again. Maybe I'll give you a couple hints that can help you out. So this first problem, it asks us to write an equation representing the cost of the trip. Let P be the cost of the park pass. So it says the youth group is going on a trip to the amusement park in another part of the state. The trip costs each group member $150, which includes $85 for the hotel and two one-day combination entrance and meal plan. So write an equation representing the cost of the trip. So when we look at this, your hint here is that we're looking at the total cost is $150, and then you have 2 of the park passes. Alright, so you have got 2 of the park passes, $150 is your total, and it's $85 for the hotel. So think about how those relate to getting your total cost, and go ahead and write your equation. Once you write your equation for this one, I'm not going to really need to give you any hints on how to solve the equation. That one should be pretty self-explanatory. So go ahead and work through that. If you need any more hints on the second part, we'll talk about that here in a second. As we come down to the second part, kind of along the same question, this one asks us, suppose you want to buy your favorite ice cream bar while at the amusement park, and it costs $2.89. If you purchase the ice cream bar and 3 bottles of water and paid $10 with a $10 bill and received no change, then how much did each bottle of water cost? So we're looking at all of our expenditures add up here to a total of $10. We paid $2.89 plus 3 times however much the water costs. So you should be able to write that as an equation. In terms of giving you hints on how to solve this one, Shouldn't really need to do that. Just be very careful with your decimal locations as you're adding and subtracting values and multiplying and dividing values. As we swing to the other side, hopefully you've got a good beat on these problems. Go ahead and try it on your own before I give out any hints, and then check in with the hints to see if those jive with what your answer is. This one says Charlotte receives a weekly allowance from her parents. She spent half of this week's allowance at the movies, but earned an additional $4 for performing extra chores. If she did not spend any money and finish the week with $12, what is Charlotte's weekly allowance? So when we look at this, she spends half of whatever that value is. It tells us that we're going to use the unknown A. She spends half of her allowance, but adds 4 to it and ends up with 12. So walking through that, you should be able to write an equation. As you're getting ready to solve the equation, the one thing I will ask you to think about is inverse operation for multiplying a fraction. Again, we've talked about this a couple times before, but you can substitute that with multiplication of the reciprocal instead of thinking about it, because really if you're dividing by that fraction, your goal is ultimately going to be multiplied by the reciprocal. Alright, it says Charlotte's goal is to save $100 for her beach trip at the end of the summer. Use the weekly allowance you found in Part B to write an equation to determine the number of weeks Charlotte must work to meet her goal. Let W represent the number of weeks. So you're going to find out how much allowance she has in this particular problem above, and really you're going to say that you need that total to equal 100. And I think in this problem what you're really supposed to be assuming is that she saves every dollar of her allowance and nothing else over these week-long periods. In looking at your answer to Part C and based on the story above, do you think it will take Charlotte that many weeks to meet her goal? Why or why not? So thinking about this, you're thinking kind of, this is the ideal situation where she saves every bit of money, and you can kind of go back up and compare that to what's actually happening, and determine kind of whether you think it will actually take her that number of weeks. Maybe it'll take her more, maybe it'll take her less. Tell me why. So as you finish with this problem, your next problem, coming down here, it's the travel baseball team problem. Work through this one as best you can. If you need a couple hints, load back up the video and we'll get it going. It says Alan is very excited about joining a travel baseball team for the fall season. He wants to determine how much money he should save to pay expenses related to his new team. Players are required to pay for uniforms, travel expenses, and meals. If Alan buys 4 uniform shirts at one time, he gets a $10 discount, so that the total cost of the 4 shirts would be $4. Write an algebraic expression here. So this is a discount of $10, so that's going to be taken away from the price of what it would normally be if it was 4 times the regular price. So we're using the variable x for our regular price, and we're being told that 4 times that regular price minus $10 would give us the total of $44. That should be allowing you to write the equation. When you're ready to solve the equation, just be very careful and make sure that you're paying attention to what your inverse would be if you have a subtraction. What is the cost of one shirt without the discount? So that's solving for x. Then it says, what is the cost of the shirt with the one discount? So here you're thinking about the unit rate, finding out what your total cost is for the 4 t-shirts, it actually tells you, is $44. And if you're buying 4 t-shirts and you're paying $44, how much is that really costing you per t-shirt? That's finding the unit rate, dollars per t-shirt. How much more do you pay per shirt if you buy them one at a time? So here you're thinking about, your hint is that you're thinking about what's the difference between this original cost and what you find out is your unit cost after the discount. Hopefully you've gotten through those other problems. Go ahead and pause a second and work through this one before I try and give you any hints to help you out. So looking at this one, it says Alan's team is also required to buy 2 pairs of uniform pants and 2 baseball caps, which total $68. A pair of pants costs $12 more than a baseball cap. Alright, so this one's definitely going to take a hint here. You can have C be the cost of the baseball cap, and you can represent the cost of the pants in terms of the cost of the cap. So we know that the cap is C dollars, and if the pants are $12 more, that means the cost of the pants would be C plus 12. So think about that as you're writing your equation. This equation obviously is going to have some parentheses in it as you're grouping the cost of the pants as being C plus 12. When you're solving the equation, you're going to have to do some simplifying of the equation first before you can legitimately solve it using inverse operations. So think about doing distributions, combining like terms, all of those other skills that we've learned. You're going to find the cost of the cap. And then once you've found the cost of the cap, then you can use this idea that the pants cost $12 more to help you find the cost of the pants. Alright, so hopefully at this point you've gone through, you've completed all of those problems. I'm going to jump back in the video and we're going to go ahead and figure out what it would be when we actually find the value here. Now that you've already solved this, let's do just a quick walk through the solutions here. We've got, coming over here to the left-hand side, we have 2 of the park tickets. 2 times P plus 85 gives $150. As we solve through that, we're going to get that we get $32.50 for the park entrance. Looking at our problem over here, we have 3 times the amount of 3 times the cost for the water, since there are 3 waters, plus the $2.89 that we spent on ice cream. So that gives us $10 that we spent in total. As we solve this, we're going to get 3W plus $2.89, kind of solving through. Just careful on that subtraction. Make sure you're lining up your decimals. $10 minus $2.89 is going to give us $7.11. So I had some missed math there. And when we calculate that out, that should give us $2.34. So looking at this one, we have half of her allowance spent, but then she adds $4 more because she does some more chores. She gets $12. Solving the equation here, notice my work for the multiplicative inverse is multiplying by the reciprocal. In this case is 2 over 1. When we go through and solve that, we see that her allowance is $16. Now, if I'm thinking about using my answer from part B, it's going to be 16 times W, 16 times the number of weeks to equal 100. As I go through and solve that, I'm going to get that W is equal to 6.25, so it's going to take her 6.25 weeks. However, I think that it will actually take her longer because she's proven that she saves less than that in a given week. Up here we see that she only was able to save $12 even after she did she got $4 extra from chores. So I think it'll take her longer because she's spending some of the money instead of saving 100% of her allowance. Looking through here at the travel baseball team, so we see that he buys 4 uniform shirts at the regular price. That'd be 4 times X, but then they're discounted. They take off an extra $10, and so we get 44. 4 times the original price minus the $10 gave us the 44. As we go through and solve that, making sure that we add positive 10 to both sides, that gives me 4x is equal to 54. So my cost is $13.50 per t-shirt at the regular price, because x was equal to the regular price. The cost of one shirt on the discounted, well, it's $44 for 4 shirts, so 44 divided by 4 would tell us that discounted they come out to $11 per shirt. So our difference there between $13.50 and $11 is actually $2.50. As we look over here, this is the one that gets pretty complicated here. We have 2 times the amount of the cap, and we have 2 times the amount of the pants, and we said that the amount of the pants was C plus 12, so 2 times C plus 12. As I come through here, I'm going to do some simplifying of this equation first. I'm going to distribute. That's going to give me 2C plus 24. I'm going to combine my like terms. 2C plus 2C gives me 4C. Now I have a simplified equation. 4C plus 24 is equal to 40. Do the additive inverse, do the division, and I get the cost of the cap is $6. What is the cost of one pair of pants? Well, that's $12 more than the cost of the cap. So 6 plus 12 is equal to 18. Then really quickly I came down here to just double check. If I had 2 times my pants and 2 times my caps, would that come out? And absolutely, the quick check on my work shows that that information does come out. Alright, so hopefully you're feeling pretty confident and prepared for your unit assessment tomorrow. Please go ahead and flip on over to your alone time and complete your alone time problem.